Okay guys and girls, we have a transverse wave over here. Okay, and before we even look at what is asked of us, let's have a look at what we have. Okay, so we have our transverse wave, and we go one wave, two waves, three waves. We see this 4 seconds. They tell us that this is seconds, so we see half a wave takes 4 seconds. Okay, we see that a wave and a half, so a full wave and a half a wave takes 12 seconds. And then we also see that all 3 waves took 24 seconds for 3 waves. Okay, then we also see that we have the 7.5 meters, right? And it's very important for us to go and see what that is pointing at. So it's from B, so it's from this point to this point, right? So from yellow star 1 to yellow star 2, that is 7.5 meters. Okay, and I need you to be able to see that this is one wave, and then when we continue to the next part, we have 2 waves. So this 7.5 meters is for 2 waves. That is how long 2 full waves are. Okay, the other information on this image is that we have points A through H. Okay, point A at the rest position, point D at the rest position, point F at the rest position, point B at the top, point E at the top, and then point C at the bottom. Alright, and now we can start looking at some of the questions. The first question is to write down letters that include 2 pairs that are in phase. Right, so remember, in phase means they're like at the same spot. So B and E, they are both at the top of this wave, at the peak, so that is a pair that is in phase B and E. And then A and D are in phase because they are at the rest positions, but specifically the rest positions where the wave begins, you see, and then at point D the second wave begins. So A and D are in phase with each other, and B and E are in phase, and so that is the first answer when they ask us to write down 2 pairs of points in phase. So we said B and E is the one pair, and AD is the other pair. Then they ask for points that represent the amplitude. So the amplitude is from the rest position to the highest position, so that's of course in a straight line. So that would be from B to I, or from I to B. That is one way to represent the amplitude, or we could say from I to H, or from H to I. So I'm gonna go with B to I. So from B to I is where we have our amplitude. Okay, and then these ones are just straight observation. They want a trough, so C is the only trough, so that is point C. And then they ask for a crest. We can either say B or E. Let's go with E. So there's a crest. Okay, and now we get to the calculations, and I'm hoping I can have it on the slide all at once. Let's see if I can make this work. I don't think so. Okay, so they want to know a wavelength. Okay, so they want to know what is the wavelength. So let's have a look here. 2 waves, so 1, 2, from here to there. 2 waves are 7.5 meters, right? So we can say that 2 wavelengths is 7.5 meters, and so therefore one wavelength is half that, right, which is going to give us 3.75 meters. Okay, so one wave is 3.75 meters long because two full waves were 7.5. Okay, two full ones, and so a single wave would be the half of that. Then they ask us for the period, and by definition the period is how long it takes for one wave to complete. So we have the time intervals here. Okay, it takes 4 seconds for half a wave, so that would mean it takes another 4 seconds for the other half. So the full wave here took 8 seconds to be fully completed, and so the period of this wave is 8 seconds. 8 seconds for a single wave to come to completion, and so the period represented by a capital letter T is equal to 8 seconds. Okay, the next one is the frequency, and I gave you a little formula bank here. So frequency is 1 over the period, which is 1 over 8 hertz. Okay, so we have the frequency. At this point I would write down all the information I have. I have the wavelength, which is 3.75. I have the frequency, which is 1 over 8, and I have the period, which is 8. Okay, so now we get to the last question, which is the speed. So we go speed is equal to frequency multiplied by wavelength. The frequency we found to be 1 over 8. Okay, so we go 1 over 8 multiplied by a wavelength of 3.75, and that gives us an answer of 0.468, which we round off to 0.47 meters per second for the speed of this wave. So this wave is moving very, very slowly, and that is logical because it takes 8 seconds for one wave to complete. Okay, so it takes a while for the wave to come to completion, and so therefore the speed of this wave is very, very low. Okay, I want you to also know that we could have done this using the grade 9 mathematics formula, where we go speed is equal to distance over time. So I'm going to do that over here as an alternative. So if we say that speed is distance over time, we need to figure out what is this distance, or any distance, and what is the time. Okay, so we know that one wave took 8 seconds, and we also know that that one wave is 3.75 meters. So we can use this 3.75 meters for this wave over the time to say that the speed is 3.75 meters over 8 seconds, which gives us the exact same answer of 0.47 meters per second. Okay, and that is the full solution to this question. Here's the image should you want to redraw it, and here are the answers. Okay, I think question 2 are the ones that you will be most interested in, so here are the answers to that. Thank you very much.